Approximately 20% of the falls that occur in construction occur or are related to the collapse or tipping over of the structure on which the worker depends. This includes heavy equipment rollovers. To understand why a vehicle rolls over, one must understand the concept of the center of gravity. The center of gravity is a point through which the force of gravity can be said to act on the vehicle. It is the balance point of the vehicle and is dependent on the distribution of its mass. Heavy equipment rollovers can occur when the force of gravity acting through the center of gravity of the vehicle shifts from a point between the wheels or track to a location outside of its wheels or track. This shift occurs most often when one track or set of wheels drops below the second set, such as when the equipment is perpendicular to a slope. The steeper the slope or offset of the wheels or track, the more likely a rollover will occur. Vehicles with a high center of gravity caused by having a larger portion of their mass higher off the ground are more likely to roll over. This can be illustrated with these scale models. For this reason, we keep loads close to the ground when transporting them. Each piece of heavy equipment is weighted differently and may be more or less prone to rollovers. You need to understand that rollover characteristics of the equipment you are operating. Let's look at some of these situations where rollovers are more likely to occur. Heavy equipment must be transported to and from the work site on the back of a flatbed truck or a trailer. Once on site, equipment is either unloaded or loaded. Hold it, hold it, hold it! You got to pull up! Straighten it out! Equipment rollovers will occur if a wheel or a track slide off the bed or ramp while loading or offloading the equipment. Let's look at a real example. A 28-year-old operating engineer was unloading a bulldozer from a flatbed trailer that was parked across a 7% inclined roadway. As the operator backed the bulldozer toward the rear of the trailer, its metal track cleats slipped on the metal surface portion of the trailer and slid down grade toward the trailer's edge. The bulldozer slipped off the edge and overturned onto its left side. The operating engineer was not restrained and was fatally injured when his head struck the bulldozer's rollover protective structure as he attempted to jump clear. The seatbelt in the bulldozer had been removed. This was a tragic accident. How could it have been prevented? Probably the most important factor in preventing this and other rollovers is to make sure the trailer is level. An unleveled bed, even that caused by positioning one set of tires on the crown of the road and another by the curb, will cause the equipment to move laterally across the bed if the tracks or wheels lose traction. In addition to a level bed, wheels on the truck and bed should be chocked to prevent it from moving. Chains should be removed and clear of the equipment so they cannot catch on the equipment and pull it out of alignment with that ramp. What you want to make sure at all times that your chains are completely removed from the trailer. What can happen is a chain can get caught and twist the machine as you back up. You will also want to make sure that there is nothing on the bed that will decrease traction and cause the equipment to move laterally, such as ice, snow, spilled motor oil, hydraulic oil, or antifreeze. Once the vehicle starts moving laterally on the bed, it cannot be stopped. The bed should also be free of debris, such as wood or any other hazard that may knock the vehicle out of alignment with the ramp. Finally, the ramp must be capable of supporting the weight of the equipment. Equipment operators must always adjust to environmental conditions, such as snow, rain, and sleet, especially when loading and unloading a trailer. An operator should also have a spotter to assist in this dangerous operation.
There's a few points I'd like to add as far as safety when you're loading and unloading equipment to help prevent rollovers or sliding of the equipment off of the lowboy or trailer. Of course, you know, with rubber-tired machines, it's a lot easier to load the machine because you can drive a rubber-tired machine up on steel plating much easier. But when we're talking about bulldozers and excavators that have metal tracks, Now we're talking about a metal-to-metal surface contact when you're trying to load a piece of equipment. Now, if that lowboy has a high angle of attack that your piece of equipment has to roll up, or your excavator or dozer has to climb to get on that trailer, well, now we have the possibility of metal-to-metal slippage on the trailer, and your machine now having the possibility or possibly sliding off of the lowboy, which could possibly cause a rollover. Now, a couple ways to help with that incline is, number one, we would take some wood dunnage, which is some cribbing, 2x4s, 4x4s, things of this nature, to decrease our angle of attack. It's a much smoother transition, less angle, which in turn gets us up easier onto the back of the lowboy. Secondly, what a lot of the operators do is they bounce the machine using your bucket or ram or hoe or dipper, whichever you like to use, closer or further away from the machine to help with that balancing, so that when the machine teeters, it makes a nice smooth transition onto the trailer or onto the rams.
Heavy equipment rollovers may also occur when equipment is operated on uneven terrain, or even when working or traveling too close to embankments. Tracks or wheels can fall into holes, slide over the edge of an embankment, or fall off an embankment if the footings give way. As mentioned previously, if heavy equipment is operated perpendicular to a slope that is too steep, the force of gravity acting through the equipment's center of gravity may also force a rollover. Let's look at a couple of real examples. A 54-year-old operating engineer, a member of the International Union of Operating Engineers, was employed by a construction firm that was building a road through the mountains. The engineer was clearing a secondary road of snow with a D7 Caterpillar bulldozer. The bulldozer slid on ice and over an embankment, overturned, and came to rest 150 feet below the road. The engineer, who was not wearing a seatbelt, was thrown from the bulldozer and crushed beneath it when it came to rest. The bulldozer's rollover protective structure was not significantly damaged. A 58-year-old experienced heavy equipment operator was driving to a logging camp from a work site in a front-end loader equipped with a rollover protection system. Road beds consisted of compact dirt and crushed rock. The road surface was wet with some puddling. Visibility of the road edge was good. 62 feet of tracks on the road indicated that the loader moved to the edge of the road before sliding off the road and down the slope, rolling over as it fell 150 feet. The engineer was not wearing a seatbelt, was ejected from the operator's compartment, and was crushed beneath the loader. What lessons can we learn from these tragic accidents? There are several important lessons to be learned. First and foremost, all heavy equipment should be equipped with a rollover protective structure, as well as a seatbelt, and all operators must wear them while operating heavy equipment. When working on slopes or near embankments, be sure to inspect them and plan a proper path of travel for the work area.
One way we prevent any type of rollover when working equipment next to embankments would be to keep the embankment side or the fill side slope of that fill embankment higher than the rest of the working area. By maintaining a higher fill side, it would naturally cause the machine to track to the inner side or the lower side of the fill. This would minimize any potential of rolling over the embankment with your machine.
You will also want to avoid moving across the face of the slope. Instead, try to operate up and down the slope face as much as possible.
A couple points I like to mention when you're working slopes. Now, one thing that we like to do as operating engineers is when we're cutting a slope, we like to keep a windrow below or beneath our lowest track. And what that does is that gives us a point to where our dozer can really hook into the slope and prevent a slide, because it's like a little bumper that we have below our track. That's number one, keeping yourself a nice size windrow alongside the bottom of your track. And number two, in the event that your machine ever does decide it wants to slide on the slope, there's two things that you want to do to keep yourself safe. Number one, if your machine decides that it wants to slide down the hill blade first, you just want to turn right into the slide, keeping your machine in the gear that you're traveling in, Never freewheel, never put your machine into neutral, and just turn your machine downhill. If your machine decides that it wants to slide down the hill backwards, then what you do, same thing, you keep your machine in the gear and you just steer your machine into the turn, allowing your machine to go straight down the slope or straight down the hill that you're on, thus preventing a rollover.
It is essential that each operator understand the operational range and limitations of their equipment. Operators also need to be aware that slippery surfaces such as mud, ice, and snow can impact traction even for construction equipment with high traction capabilities such as bulldozers. Equipment operators must always adjust to these environmental conditions. My name is Bill O'Neill. I'm the Assistant Safety Officer as well as an instructor with the Operating Engineers, Local 4, Boston, Massachusetts.